Welcome learners to part 2 of study session 8, where we discussed inventory management. The meaning of inventory management. In part 1, reason why organization keep stock. We also introduce ourselves to economic order quantity, the assumptions of economic order quantity. And here we are in the part 2 to explain further what economic order quantity mean by working examples of how to calculate or arrive at economic order quantity. Giving example 8.1, a company uses 50,000 widgets per annum, which costs 10 naira per unit. That's the purchase price. Ordering cost is 150 naira per order, and carrying cost is 15% of the purchase price per annum. So we are to calculate the economic order quantity. So we write out the formula for calculating the economic order quantity. The economic order quantity is also denoted by Q. In some text or in some examples, you see it written out as Q. It's also called, they are also referring to the economic order quantity. So the formula for arriving at economic order quantity is 2 square root of 2 multiplied by D multiplied by OC, all divided by CC, where D stands for our annual demand, OC stands for our annual ordering cost, and CC stands for our annual carrying cost. This formula is derived from the formula of annual ordering cost and annual carrying cost. That's where the formula is derived from. But because of time, we won't be able to illustrate how we arrive at this formula. But as for our annual ordering cost, as for our annual carrying cost and annual ordering cost, let's say our annual carrying cost is denoted by Q multiplied by our carrying cost over 2, while our annual ordering cost is denoted by what? Q multiplied by our annual ordering cost divided by D multiplied by our annual ordering cost divided by Q. So that's how we arrive at our annual carrying cost and our annual ordering cost. Don't forget, the economic order quantity is that quantity that equates the annual carrying cost with the annual ordering cost. So the equation of this formula is what results into our Q, that is our economic order quantity. So back to our question or the problem that we are to solve. So we identify our D, that is our annual demand, to be 50,000 units. Our carrying cost to be what? Our ordering cost to be 150 naira, and our carrying cost to be 15% of cost price. Don't forget, our cost price is 10 naira per unit. So we find 15% of the cost per unit, which is 15% of 10 naira. And at the end of the day, we have 1 naira 50 kobo for our annual ordering cost per unit. For our ordering cost per unit. So we substitute for these values in what? In the formula. So 2 multiplied by 50,000 multiplied by 150 all over 1.50. So all squared. At the end of the day, we have 3,162 units or 62 widgets. Our Q equals 3,162 widgets. So that's for illustration. Example 8.1. Example 8.1, we are to calculate what? The economic order quantity only. But as for example 8.2, we have this local firm, a local distribution for a national tire company, expect to sell approximately 9,600 steel belted radial tires of a certain size and treat design next year. Annual carrying cost is 16 naira per tire. Ordering cost is 75 naira. The distributor operates 288 days a year. Problem: what is the economic order quantity? How many times per year does the store reorder? How many times per year does the store reorder? That is the reorder cycle. What is the length of another cycle? What is the total annual cost if the economic order quantity is ordered and the unit cost is 100 naira per tire? To the solution, our EOQ, we substitute our values in our formula. So our D is 9,600 units. Our ordering cost, annual ordering cost is 75. Ordering cost per unit is 75 naira and our carrying cost per unit is 16 naira. So we substitute for those values in our formula and we arrive at our Q to be 300 tires. So as for the second part of the B part, number of order per year, that is how many times do this company or do this distributor orders in a year. So having our demand to be 9,600 units and we've calculated our Q to be 300 units. So our number of order per year equals demand over Q or demand over EOQ. So that's 9,600 over 300, 32 orders. So that means the local distributor orders 32 times in a year. Length of order cycle. Our length of order cycle is our Q, our EOQ over our demand. And then we have 1 of 32, 1 over 32. And don't forget that our working days in a year is 288 days. So we multiply our 1 of 32 by our working days. There we get our length of order cycle. Our length of order cycle in a year. So our length of order cycle is 9 days. Then the D part of the question is total cost, calculating our total cost. When you come across some text, they calculate their total cost using annual carrying cost and annual ordering cost. Some ignore using the purchase cost, including the purchase cost in calculating the total cost. But as far as this example is concerned, we will be using the purchase cost in arriving at the total cost. So our total cost is a function of our purchase cost, annual carrying cost, and our annual ordering cost. So the formula for our purchase cost, that is the item cost multiplied by our quantity demanded or quantity ordered in a year. Our annual cost, our Q multiplied by our carrying cost. Our annual carrying cost, which is our quantity multiplied by our carrying cost per order, divided by 2. Same here with our annual ordering cost. So we substitute our values in this formula, and at the end of the day, you can see that our annual carrying cost equals our what? Our annual ordering cost. So that's the logic of the EOQ. Is that quantity, our Q, that what? Is that quantity in which our annual carrying cost equate and our annual ordering cost. And you can see it clearly here that at the end of the day, given our Q, our annual cost equals our annual carrying cost equals our annual ordering cost. So we sum everything together, and at the end of the day, we get our total cost to be 964,800. Thank you for listening. We meet at the next session.